In today's class, we will be seeing how to find out inverse of a matrix using column operations. So we are again going to take up questions from exercise 3.4. And I will start with question number 4. Square matrix is given. Let us consider this is matrix A with elements 2, 3, 5 and 7. Now since we are using row operations, so here we have to remember that for using column operations, the matrix equation has to be A is equal to matrix A into identity matrix, where we perform column operations in matrix A and in the identity matrix. So the matrix equation is matrix A. On the right side, since we are not making changes in matrix A, it remains as such, and an identity matrix of same order. So here in column operations, we know that matrix A on the left hand side has somehow to be converted into an identity matrix, and while performing column operations, we will ensure that corresponding rows of the identity matrix are obtained. So suppose we want to obtain the first row here, accordingly we want this element to be 1. So because this element is in the first column, let us perform an operation of this kind. 2 times C1 minus C2. So you can check here, 4 minus 3 will give us 1. So performing this operation in the first column, first element is 1, 10 minus 7, 3. The second column remains as such. On the right hand side, twice C1 minus C2, twice of this minus 0, twice of this minus 1, and the second column. As I have said, while using column operations, we will ensure that the row elements are obtained. So this is the element we want to convert to a 0. This element is in the second column. So changes in second column as C2 minus 3 times C1. 3 minus 3 times 1 will give us 0. So first column remains as such. Performing this operation, this element is 0. 7 minus 3 times, that is minus 2. On the right hand side, first column is same. Second column, 0 minus 3 times. This minus 3 times gives us 4. So after 2 column operations, we have obtained the first row. Now in the second row, we want this element to be 1. So for this, because the element is in the second column, this plus this element will give us a 1. So C2 plus C1. First column will remain as such. Second column, this plus this, 1, this plus this, 1. So if we just stop here and see, desired 1 has been obtained, but the initially obtained 0 has changed. So this operation is not valid here. Think of something else. What is the other thing we can think of? Divide the second column by minus 2. So we are multiplying elements of the second column by minus half, and we obtain the first column 1, 3. The second one is this. On the right hand side, first column remains as such. The second column, minus half of this, 3 minus half of this, minus 2. So now our last step, where we need to convert this into a 0. The element is present in first column and is in the first column. So first column minus 3 times element of the second column. So using this operation, the identity matrix is obtained on the left hand side, and on the right hand side, what will we have? 2 minus 3 times, that's minus 7, and minus 1 plus 6, this is 5. The second column elements remain the same. So once again, we know that identity matrix can be written as a matrix multiplied by its inverse. Hence, the inverse of the given matrix is this matrix. The inverse exists and is this. Now, before you started performing the column operations, you could have checked in the beginning here. 2 into 7, 14, minus 5 into 3, 15, which is minus 1 and is not equal to 0. So if a value is obtained which is not 0, then before performing column operations, we are very sure that the inverse of the matrix can be found. So next we take up question number 14, where matrix A is 2, 4, 1, 2. Here again, for column operations, the matrix equation is this. Writing the matrix equation, we know this element has to be converted to 1. So this can be easily obtained by interchanging columns 1 and 2. Performing the same operation on the right hand side, interchanging columns, we get this. In column operations, we look for rows. So this element has to be converted into a 0. The element is in second column. So second column elements minus twice of first column elements. The first column does not change. Performing this operation, 0. This minus this, 0. And before you find out the right hand side, you can see that all the elements of one column have converted to 0. This simply means that the inverse of the matrix does not exist. You can find out here the right hand side also. So first column is this, second column this minus twice, and this minus twice. Sorry, this is element 1. So A inverse does not exist. You could have checked it in the beginning also. 2 into 2, 4, minus this product which is 4. This difference is coming out to be 0. So this indicates that the inverse of the matrix will not exist, which after column operations we have found so. So next we are going to take up question number 17. 17th question, a 3 by 3 matrix is given. First column 250, second column 0, 1, 1, third column minus 1, 0, 3. Now we know for column operations, this is an important statement and should be written in every question. For column operations, the matrix equation is this. The matrices are on the right side the identity matrix of same order. So here in the first row we want to obtain a 1 here. This element is in the first column. So performing an operation like C1 plus C3 minus 2 plus minus 1 will give us a 1. So performing this operation, first column is 1, 5, 3. The second column and the third column does not change. Performing the same operation here, C1 plus C3, second column and the third column. So in the first row 1 and 0 has been obtained. This has to be a 0. This element is in the third column. If we add to the elements of third column the elements of first column, this element will become 0. So the first column is same, second column is same, and the third column. Performing this operation, 0, 5, 6, And likewise on the right hand side, the first column is same, second column is same, performing the operation C3 plus C1, 1, 0, 2. So first row has been obtained. In the second row, this 1 also has been obtained. What we want in the second row is a 0 here and a 0 here. So this can be converted into a 0. We are performing an operation C1 as C1 minus 5 times C2. So the first column, this minus 5 times is 1, this minus 5 times 0, this minus 5 times minus 2. There is no change in the second column, it will remain as such. The third column we'll write a little later. On the right hand side, the first column performing the same operation, this minus 5 times is 1, this minus 5 times and this minus 5 times. The second column is the same. And now for the third column, because in the same step we are converting this element also into a 0, so the corresponding column operation would be C3 minus 5 times C2. So this minus 5 times 0, this minus 5 times is 0, this minus 5 times gives us 1. On the right hand side, this minus 5 times, this minus 5 times, and this element is 2. So second row elements have been obtained. In the third row, this 1 is already here, so we need to convert this and this into zeros. So I'll start from here. This element is in first column, so first column plus twice of third column is minus 2 plus 2 times this will give us 0. So the first column, this plus twice 0, this plus twice 0, this plus twice 0. First column obtained. Here the third column will remain the same. Second column we'll write down later. Making changes in the first column, this plus twice of this 3, minus 5 plus twice of this will give us again minus 15, this plus twice 5, and the third column is this. Since this element also has to be converted to 0, so performing an operation in the second column as second column minus third column. So this minus this 0, 1, 0. Identity matrix obtained here. Performing the operation here, minus 1 is 6, minus 2. And now we can compare. I is A into A inverse. So comparing, we get inverse of the matrix is a matrix with this as the first column, second column, and the third column. Now in this video we have used column operations where we are using this equation for column operations. In the previous class when we were using the row operations, our equation was of this kind. Now the question is, why do we have this equation for row operations and this equation for the column operations? This explanation is given in the link given in the description box below.